Hi, these are questions 6, 7, 8, 9, 10 of the review for test 1. So I'll start with number 6, which is a distance, rate, time question. It says, Ryan drove to the mountains last weekend. There was heavy traffic on the way there and the trip took 7 hours. When Ryan drove home, there was no traffic and the trip only took 4 hours. If his average rate was 27 miles per hour faster on the trip home, how far away does Ryan live from the mountains? So the first thing that I recommend is to try to identify what kind of question this is. Obviously we're talking about distances and rates and time, so this is a distance, rate, time question. So what I like to do is, if you write the formula, distance equals rate times time, and then create a box for the two different travel events. So the first travel event was going there, and then the second one was coming home. And then we just fill in the boxes. So going there, what was the distance? They never told us what the distance was. In fact, that's what they're asking for. How far away does Ryan live from the mountains? So I don't know the distance, so I'm going to put D. But what I do know is that the distance there should be the same as the distance home. So both of those are D. Okay, what was his rate on the way there? So let's see. His average rate was 27 miles per hour faster on the trip home. So I don't know his rate on the way there, so I'm going to call that R. But on the way home, it was 27 more than R, because he was going faster on the way home than he was on the way there. And then finally, they did tell us on the way there it took him 7 hours, and on the way home it took him 4 hours. So now I have my setup, and I can write each of these as an equation. So here I have D equals R times 7, which we would typically write as 7R. We usually put the number in front of the letter. And then I've got D equals 27 plus R times 4. So I could put my 4 there. Notice because I have 2 terms in there, I put it as a parentheses. So how can I solve this? Well, what I'd like to do is use substitution. So if I know that D equals 7R, then I can replace the D in the second equation with 7R. So I'm going to rewrite this equation as 7R, because that is what D is, equals 27 plus R times 4. And now I have an equation that only has one variable, R, so I can solve it. So I'm going to distribute my 4. So 7R equals 4 times 27 is, 108, I believe. And then plus 4R. So I can subtract 4R from both sides to get 3R equals 108. And then my last step is to divide by 3. Let me see if you guys can still see this. Almost. So I'm going to rewrite this up here. So 3R equals 108, divide by 3. I get R equals 36. Okay, did I answer the question? No, I found the rate, but they want the distance, right? How far away does Ryan live from the mountains? But if I know the rate is 36, and I knew that distance was 7 times the rate, then I can plug it back in here. So I get distance is 7 times 36, which is 252. And then that would be miles, but I don't think they asked you to do the miles. So 7 times 36 should be 252. I'll just double check. Yes, 252. And that's how you do that question. All right, let's move over to question number 7. So another story problem. And most people really have a bad reaction to these acid problems. And I think it's because we're just not as familiar with that. Like, we're not chemists for the most part. We don't dabble with acids. Unlike, distance, rate, time, of course, most of us drive, and we've definitely traveled, whether it's walking or bicycling or driving, so that's a little more familiar, and this is not. But the setup is kind of similar. I have two unknowns. I need to find an equation and solve for what they're asking for. So here it says a chemist mixes 100 milliliters of a solution that is 75% acid with 25 milliliters of a solution that's 35% acid. And they first want to know how many milliliters of acid are in the resulting mixture, and then what percentage of the resulting mixture is acid. So notice we have two different things going on. We have quantities, which are milliliters, and then we have percents acid, right? Those are our two things, our two variables. We have an amount of liquid, and then we have a percent acid on the liquid. So what I do is I start with something that's very easy. I think the hard part is the acid. But if I was just to ask you, well, what's happening with these two items? They're just putting them together. So I have 100 of those, and I'm adding that to 25 of the other. And to make this an equation, I would go together, that equals 125 milliliters of my solution. And most people are comfortable with this. I have 100 milliliters of something added to 25 milliliters of something, gives me a total of 125 milliliters of something. So what do I do with the acid? Well, acid is a percent, and percent never stands by itself, because we never just go, oh, hey, I got 10%. You'd be like, of what? 10% of, what, right? It's always of what, and the word of means multiply in math. So what we're going to do is we're going to tack these percentages onto each quantity as a multiplier, okay? So 100 milliliters of a solution that is 75% acid. So this solution here is 75% acid. 25 milliliters is 35% acid. Notice I put it in as a decimal and took out my percent sign to get a total of some quantity, which I don't know, of acid, right? So if that's my unknown, I'm going to write that as an x, and it's being multiplied. So, we're more used to doing this, putting that unknown x on the right side of the number. So now I just need to solve this. So 0.75 times 100 is 75, plus 0.35 times 25, I'm going to do on my calculator, and I get 8.75 equals 125x. So 75 plus 8.75 is 83.75 equals 125x. And the last thing I would do is divide both sides by 125. And make sure I'm still, sorry about that. So I'm gonna, now you can see it. All right, so let me get my calculator out. I have 83.75 divided by 125, and I get 0.67. So what does that mean? Well, I just got x is 0.67. X equals 0.67. X was the amount of acid on my total. So the amount of acid here, so it'd be 67% acid for my mixture. So how many milliliters of acid are in the resulting mixture? And we actually had already answered that question over here. It was 83.75 milliliters of acid, because we did this acid times that, together that was 83.75. What percentage of the resulting mixture is acid? 67% is acid. If you weren't sure how to get that. Maybe this didn't make sense to you. Well, what is 67% times 125? So 0.67 times 125 will give you your 83.75. So that's two ways of going about that. The more you do this problem, the less intimidating it will be. Like, do the exact problem 3 or 4 times until your brain starts to get used to what's coming next. And then try a problem that has different numbers. Okay, so let's go to question number 8. Up there. There we go. This is an absolute value equation because it's got the absolute value symbols and it's an equal sign. So it's absolute value equation. And the way that we solve these is step 1, we isolate the part that's the absolute value. So currently I have the absolute value of w minus 3. I need this 6 to move to the other side so that I have the absolute value all by itself. The next step is we generally create 2 equations. The first one, we drop the absolute value symbols and just write it as it is. The second one, we do the same thing, but we change the sign of the number on the right side of the equal sign. Now in this problem, it doesn't matter because -0 is still 0. Like, we'll get the same answer. So we're only going to get one answer out of this question. Had this been a number like 4, then this would have been w minus 3 equals 4, w minus 3 equals -4. That would have been 2 different equations to solve, and you would have gotten 2 different answers. So anyway, but for this problem, I get w equals 3. This would be the same thing because -0 is also 0. So I only get one solution for this question. And the answer is w equals 3. All right, let's look at question number 9. They give us the picture of this number line, and they want us to write it in interval notation. No, not in interval notation. They want us to write it as an inequality, which means you will see inequality symbols in your answer. So what is this telling me? So it's shaded to the left of -4. So that means it's talking about all values, we're going to call those values x, that are smaller than -4. Here we have all these values that are greater than or equal to 6, because this is colored in, so I have the or equal to part. So I have both of these inequalities in this picture, so therefore I do a union to represent that it includes both parts of that picture. So x is less than -4, union x is greater than or equal to 6. All right, the last question on this review video is number 10. So 10 is an inequality. I'm solving this inequality. Solving inequalities is the same thing as solving an equation, except for one rule. If you multiply or divide by a negative number, then you have to change the direction of the inequality. And that's the only real difference. So let's see if we have to do that here. So I'm going to subtract 1 so that I can move the non-y terms over there. So I get 20 is less than or equal to 4y. And then I'm going to divide by 4. Now, the rule was if I multiply or divide by a negative, which I'm not, I'm dividing by a positive 4. Had it been negative, then I would need to change the direction of my inequality in the next line. But I don't. So this is 5 is less than or equal to y, and that's the answer to that one.